Now dear student, we are going to discuss question number 5.2, and in this question again we have sub part of this question, clear. So now we are going to start each part one by one. Number 1, in this question it is given answer the following questions. Okay, part number A, the earth magnetic field varies from point to point in space. Okay, fine. Does it also changes with time? If so, what time scale does it change appreciably? Now listen carefully. First of all, if I am talking about earth, let's suppose if I draw here, let's suppose you can assume this is earth, clear. Here we have geographical north, clear. Here we can say this is geographical south, clear. If you let's suppose if you are taking a plane and that plane is actually passing through geographical north and south, we can say that is geographical meridian, clear. But if I am talking about this one plane, this plane, clear. Now we can say here this is, we have magnetic south, or we can say this one is magnetic north. How can we say? Let's suppose if you place a bar magnet, you can assume any bar magnet that is situated at a center of earth like this, clear. Now I am taking here, this is a north pole and we can say this one is south, clear. Now if you draw here magnetic field lines, you can see magnetic field lines that is coming out from this north pole and it is going to the south pole like this, clear. And definitely inside it is moving from south to north pole, clear to you. Similarly, you can draw here magnetic field lines like this, clear. So we can say magnetic field lines is actually starting from north pole and it is going to the south pole, clear. Now you can say, if we talk about relative strength of magnetic field, definitely we will find relative strength, we will find at this position will be more. Here relative strength of magnetic field, it will be more. But if I am talking about these points, let's suppose if I am saying like this, clear. If I am talking about magnetic field at this point, definitely we can say here we are having strength of magnetic field, it will be less compared to this one, clear. So definitely we can say value of magnetic field, it will vary from space to space, but this value also vary with time. Yes, actually magnetic field value also vary with time. Let's suppose if you are considering, let's suppose you are observing this point, clear, and if you are observing value of magnetic field, clear, but it takes hundreds of years, clear. You have to wait for hundreds of years, and after that time you will find some appreciable change in magnetic field. But if we are talking about just for a few years, let's suppose 10 years, 20 years, 50 years, you will not find any appreciable change in a magnitude of magnetic field at a particular location, clear. So yes, definitely it is true, value magnitude of magnetic field, it varies from space to space, but with time definitely it changes, yes, but it takes hundreds of year time, clear. So this is all about part number A, clear to everyone? Yes. Now if I am talking about part number B, so in part number B it is given the earth core is known to contain iron, clear. Generally it is assumed that the earth, on the center of earth we have an iron, clear, and we can consider it as a bar magnet, and that due to that bar magnet we can say there is a magnetic field lines that is to be there for the earth, clear. But it is given in this question, earth core is known to contain iron, fine, yet geologists do not regard this as a source of earth magnetism. Why? Because because we know as we move from the surface of earth, and that is we are going deeper and deeper inside earth, definitely temperature and pressure increases, clear. So if we are talking about center, so at center we are having a very high temperature, clear, and at that temperature definitely we will find iron in a molten state, yes or no. So it is assumed that whenever we are talking about iron at a higher temperature and we are getting iron as in a molten state, it means definitely that temperature is above the temperature of a Curie temperature, clear. It means we can say properties of iron is changes when such high temperature is to be there, clear, or we can say its ferromagnetic property changes, clear. It means we can say yes, that's why we can say the geologists do not regarding this as a source of earth magnetism, Clear? So I think this part number B is also clear to you. Clear? Now if we talk about part number C, in part number C it is given the charge current in the outer conducting region of earth core are thought to be responsible for earth magnetism. Okay, what might be the battery to sustain these currents? Clear? Now listen carefully. Now when geologists assume that definitely at the center we have very high temperature, iron is situated in the form of liquid, so we cannot regard iron as a source of magnetic field line at that time, but it is given in this question that charge current in the outer conducting region of the earth core are thought to be responsible for earth magnetism. But geologists actually assume that there is a definitely an current that is actually flowing inside earth, so that we can assume that circular loop as a source of magnetism. Clear? Actually such as you can assume it as a, let's suppose you have a wire, in the wire let's suppose a current is flowing. Clear? So definitely whenever we have a wire and we have a current carrying wire and that current carrying wire is in a form of a loop, then at that time you can say definitely we will find magnetic field and definitely we can calculate value of magnetic field also. Clear? So same as geologists assume that definitely here we have a current carrying circular loop and due to this current carrying circular loop this magnetic field is producing. Clear? So but now we can say if there is a current, then what is the source of that current? So generally it is assumed that radioactivity is one of the source of this type of current carrying loops. Clear? Because we know in our earth we have so many minerals, we have so many natural substances, and definitely there is some radioactive substances also, and these radioactive substances are forming the we can say they are actually forming charge current. Clear? So radioactivity is assumed to be as a source of battery for this current. Clear? Now if I am talking about part number D, in part number D it is given to you the earth may have even reversed the direction of its field several times during history of 4 to 5 billion years. Clear? Now how can geologists know about earth magnetic field in such a distinct past? Now you can say, sir, we have assumed that there is a magnet at the center of earth and definitely due to this magnet we have magnetic field lines, that is clear to us. But sir, it is geologists assume that this direction of magnetic field lines is reversed after some time. How it is possible? It is possible. Clear? And how can we know for the such distinct past? Actually we know magnetic field, whenever there is some change in the magnetic field lines is to be there, that property is actually stored in a rocks, or we can say or the magnetic materials that we have found on a surface of earth. Clear? If we take that rock into consideration and if we if we find the properties of that rocks, due to that properties we can say that after 4 to 5 million years or billion years we can say earth actually changes its direction of magnetic field several times. Clear to you? So this is all about part number D. Now if I talk about part number E, in part number E it is given to you the earth field depart from its dipole shape substantially at a large distance greater about 30,000 km. Clear? But what agency may be responsible for this distortion? So definitely we know if we are talking about magnetic field due to dipole. So definitely we know that earth magnetic field is to be there and its area of expansion is very large. But let's suppose this magnetic field lines is going, that is away from earth, and as it reaches to ionosphere. So in ionosphere definitely there are so many ions is already present there, and these ions are taking their energy from solar system. Clear? Or solar energy. So we can say actually these ions are responsible for distortion of magnetic field due to earth magnetic field. Clear to you? So this is all about part number E. Now if we are talking about part number F, so in part number F it is given interstellar space has an extremely weak magnetic field of order of 10 to the power minus 12 Tesla. Fine. Can such a weak field of any significance consequence? So let's suppose we have any charged particle and let's suppose that charged particle is actually moving in a uniform magnetic field, and let's suppose I am assuming that uniform magnetic field is perpendicular to that direction of motion. Clear? So at that time I can write here radius, value of radius, this is given by mv divided by qb. Clear to you? Yes or no? So from here you can say, if we are talking about extremely weak magnetic field, clear, it means we can say this value of B is very less. Clear? So at that time you can say this value of R will be more. Clear to you? So when value of R will be more, it means we can say whenever we have extremely weak magnetic field, at that time we will find radius is more. Clear? So let's suppose if we are talking about some particular distance movement, at that time we will not find any appreciable change in a magnetic field. Yes or no? But let's suppose if we are talking about, let's suppose we are in a weak magnetic field. Clear? So definitely we can say radius of curvature is increases. Clear? So just a significance is here. If you are talking about weak magnetic field, radius of curvature is very large. Clear? And you will find that charged particle is moving approximately in a straight line. Clear? So this is all about this question. Clear to everyone?